All right, so for example 4, we're going to integrate x squared natural log of x dx. Okay, and so algebra doesn't work, u substitution won't work. This is not an inverse trig integrand, and we're certainly not going to use partial fractions. So we have a product of two of the Lipit functions, and so our technique is going to be integration by parts. So thinking about Lipit, do we have a log part? We sure do. So that's going to be our u. We're going to need its derivative. And also in the formula for integration by parts, we have dv and we have v. So we have to account for all these different parts that make up our formula. Okay, so u is going to be our natural log, and that leaves dv to be the other part of the integrand x squared along with the differential. So u is natural log of x, and dv is x squared dx. We have to account for everything. Differentiating 1 over x dx, integrating to get back to v, x cubed over 3. All right, and to help us remember the technique of integration by parts, just think ultraviolet voodoo. So we've got ultraviolet right here, this product, minus voodoo, minus the integral of voodoo, and so that would just be this product right here. Before I do enter the integrand here, just notice that I am going to have the differential dx. And I think I'll go ahead and take care of the simplification here. 1 over x times x cubed over 3. Well, this x is going to cancel when I multiply with one of these, leaving a square. So I'm going to actually end up with x squared over 3. That should be easy enough to integrate, reverse power rule. So we'll complete the problem. Increase the exponent to a cube and then divide by 3. There's already a 3 here, so that means we're going to multiply by 9. Add your constant of integration since it's an indefinite integral. And of course, with all the other integrals, you can check your work by differentiating. That would require the product rule here, a simple power rule here. Once you clean it up, you should get to this product right here. Okay, so for example 5, we're going to continue, but it's going to be a little bit different. Okay, the technique of integration by parts is still going to be applied. All right, so we know that's the technique. Think Lipit. There is no log function. I for inverse trig. Nope. P for polynomial. Yep. I'm going to let x squared be my u, and then the rest of the integrand and the differential dv. Come over here, we need u, du, dv, and v. U is x squared, the derivative is 2x dx, dv would be sine x dx, and the antiderivative would be negative cosine x. All right, and you might already be looking at the product of voodoo right here and noticing that you're going to end up with another product. But at least a linear factor is going to be easier to work with than a quadratic. So what's interesting about this problem is that we're going to have to apply integration by parts twice. So let's go ahead and work with what we have right now. All right, got the product here. Negative x squared cosine of sine x minus the integral of the voodoo. So that would be negative 2x cosine x dx. I would probably clean this up here. If I pulled the negative out, it would make it positive. Okay, so we're not done. We can see when we're going to integrate this right here. It is simpler. It's definitely simpler than this because we went from a quadratic to a linear function, but we're going to have to apply integration by parts again and coming up with maybe a different set of u's and dv's and du's and v's. Okay. All right, so let's go ahead and integrate this by parts. So going through Lipit again, we see that the u part is going to be our polynomial function 2x. Okay, and so this is better. We're going to end up at a constant 2. And let's see, dv would be what? Cosine x dx. so that that antiderivative is sine x. All right, copying this term down, realizing that this is actually, our integration by parts part of the problem. Adding, okay, if we integrate this, we integrate it back to u times v, which is what, 2x sine x minus the integral of v du. Easy enough. That product is 2 sine x dx. Okay, so one more integration, that's easy, and we'll be done. All right, and the antiderivative for sine x would be negative cosine x, and this just is a constant multiplier, so this is actually going to change to a positive. You could have taken out the 2 in front. You could bring in a negative here to make this negative sine x, but if you did that, you'd have to take out a negative here. You're going to end up with plus 2 cosine x, whichever way you proceed, and add your constant of integration. Okay, so what was different about problem 5 is that we had to apply integration by parts twice. Okay, and just imagine had in the original problem this been a cube, we'd have to go to a quadratic, to a linear, and then to a constant derivative. Okay, so that's a lot of work. I don't think I've ever seen multiple integrations. Just need to know the technique of integration by parts, and the most I've ever seen it is that you have to apply it once. But this is kind of interesting. All right, so the answer is quite complicated looking. It's made up of a couple of terms that you'd have to apply the product rule if you were going to go ahead and check to make sure that this is the correct answer. Okay, one final comment, thought, whatever, idea, probably more, a little bit longer than that, but I'll try and keep it short here. I do want to share with you something that you would see in a calculus textbook, in a college calculus class, as far as what we just did in example 5. So what we're going to do is we're going to do problem 5 a different way. We're going to use the tabular method. All right, tabular method is used when you see that you're going to have to apply integration by parts multiple times, like we did in problem 5. All right, and it's just a way to organize your work. Personally, I'm not a big fan of the tabular method unless perhaps, I had an x to the 5th power and I was going to have to use parts many times. Okay, but just for once, twice, 3 times, to me this method is one more thing to have to memorize. All right, we're going to find this answer that we found here by using the tabular method. So we're going to build 3 columns. And here they are. So the first column is alternate signs. Second column is u and its derivatives. Third column is dv and its antiderivatives. So using the preceding example, x squared sine x dx, what I'm going to do is I'm going to start with u and its derivatives. So once we've identified u to be x squared, I'm going to write that down. And what we're going to do is we're going to differentiate until we get to 0. Okay, then I'm going to come back over here and I'm going to fill in my alternate signs. It just means I'm going to go from positive to negative, vice versa. So we always start with positive, then negative, then positive, and once down here, negative, I'm done. All right, dv was sine x dx, but I'm only going to look at the integram part, the sine x. So let's look at sine x. Okay, now I'm going to find all its antiderivatives. Well, the first antiderivative is negative cosine x. That integrates back to negative sine x, and that would integrate back to cosine x. Once I've generated the columns here, okay, based on u and its derivatives until I get to 0, okay, we're going to build our answer. So I'm going to go ahead and put the problem back down here. All right, and the way we build our answer is by the signed diagonal products. Okay, so easy enough, the signed diagonal products. So here's our sign, this is our diagonal, and we're going to multiply these two together. So it's going to be positive times x squared times negative cosine x. So that product is negative x squared cosine x. And take a peek back at the last problem. Yep, that's the first term. All right, and we're just going to continue this until we run out of terms. So the signed diagonal products. So negative times 2x times negative sine x. That's going to be positive 2x sine x. And look back at your previous answer. Yep, that's the second term. So you can keep doing this. The signed diagonal product. Ooh. Positive times positive, and we end up with plus 2 cosine x. Okay, and then right here we've run out of a term to find a diagonal product. So we're done. Just add plus c. And as you can see and compare to the last answer, it is the same. So the tabular method is great, you know, but if you're only doing 2 integrations, I don't know if it's worth the time to build the column. Up to you, but I wanted you to see it, that it is an option to avoid integration by parts multiple times.